Okay, so what is a logarithm? A logarithm is simply an inverse of an exponential function. That's all there is. It's just simply the inverse. So, for example, 2 to 3 equals 8 can be rewritten like this. It's just another way of writing exponential expression, but it is actually an inverse of an exponential expression, because let's say you have like y equals 2 to the x power. What if you switch x and y? Right? And then you want to isolate y? You write as y equals log base 2x, right? That's exactly what this is. It's just simply the inverse of an exponential function. So just to rewrite, I mean, you look at the log, it's like, okay, well, 2 to some power equals 8, right? 2 to the power 3 equals 8. There you go. Very simple. The base, we always make it positive, though. The base is a subscript of the log. Otherwise, it would just be really weird if it's not. And the input of log also has to be positive as well. So you're just going to rewrite all these. I mean, it should go by pretty quickly. I imagine these notes won't take too long. So first, you're asked to write each one as an log in logarithmic form. So log base 3 of root 3 equals 1/2. Log base 7 of 7 equals 1. Log base 5 of 1/25 equals -2. Log base 3 of 8 equals x. Log base 4 of 1 equals 0. Here, 16 equals 4 squared. Here, 1/27 equals 3 to -3 power. So any questions? Pretty comfortable? Okay. Homework should be pretty easy then. So the basic properties of logs, what would you say for number 1 there? 0, yeah, because b2 0 is 1. Yeah, totally. Thank you, Ryan. b2 0 equals 1. So therefore, that's 0. How about the second one? 1, yeah, because b to the 1 equals b, so you get 1. What are you guessing about the third one? Just y, yep. That's because you could say this. I'm just going to kind of go straight to log properties. So you can just say that. So that's x. And how about the second one? What are you guessing about the second one? X again, right? The way you can look at that one, so this would be 14. The way you can look at this one is you can say trying to think of the right way to. It's a little tricky to do this one here. I guess you could say this, like, so b to some box, or actually say I did this here, equals question mark. So log b of the question mark equals log base bx. So let's place that question mark, of course, x. So I guess you could say it like that. If you wanted to set this at equals some arbitrary symbol or letter or whatever, that could work. They don't technically cancel out, by the way. It's not like the differentiation. I think some of your attempts will have to do a slash to this, apply this here. They just undo each other. Because what you do is you're putting a log into an exponential function or an exponential function to a log. And they're inverses, right? Right? Well, how do they do, we plug the inverse into this original, they undo each other. So what would you say for example 3 then? 3/2, yep. How about for the one right below it? Careful, this one. 200? Oh, 2/3, sorry, okay. 2/3. How about the log base root 3 of 9? What do you guys think?
4.
Yep, 4. 4. How about the one right below it? Yep, -1. Does that make sense, guys? I mean, why is this one? Why is that one work? Because log root 3 of 9 equals. Let's say put a box here. So 9 equals root 3. So 3 squared. See, I put a 4 there to make that work. Okay, questions? No? Okay. Let's keep on moving. 2 special types of logs. There's a common log and natural log. Common log's at base 10. Natural log's at base e. Shorthand is just log x. Shorthand here is ln x. So that's going to be 2. That's going to be 1. 0. What do you guys think for the top right? What would that be? Good. How about the one right below log 100? -3. 2. X. How about this one here? Y. This one? This one? Good. Okay, so yeah, you guys are good.
Yes.
Catherine's really good. Okay. I know on fast. Did you guys see, like for example, that's base 10, right? That's 10 to -3 power. So it has to be base 10, right? Or here that's base 10. So your x was also base 10, so you just get y. Or you can use the logic property. There's something called the power property, and the x goes to the front. When the input is power into a log, you deploy the f. Here you have to use a calculator, unfortunately. So log 34.5, ln 23.5, log 0.43, ln 0.48. So 1.54. -3.16, -0.37, and -0.73. Here x equals 10 cubed. Or x equals e to the 4 power. Just leave it like that. Okay, any questions? We're good? So this one's pretty easy to graph. I mean, if I plug in like 0, I get 1. Plug in 1, I get e. Plug in -1, I get 1 over e. And then the inverse should be easy. X equals e to the y power. So what would y equal after I do an inverse? Good. And remember, when we do the inverse, you have to switch the columns. There we go. And remember, they're always going to be reflective. About y equals x. Very, very important. And so that's the natural log of x. We see that. It's log base ex or ln x. Very simple stuff. Any questions on that so far? No? So I'll review hopefully. Okay, good. That's good. Because after ski week, we'll could start doing calculus. All right. Here we go. Fill in the blanks for e to the x. The domain is all real numbers. The range is from 0 to infinity. It's continuous on all real numbers. Sorry, I lied. Wow, I can't. Sorry, guys. I was thinking e to the x. My bad. My bad. 0 to infinity. My bad. And that's all real numbers. And it's continuous from 0 to infinity. It's increasing also from 0 to infinity. There's no symmetry. It's not bounded above or below. As x approaches infinity of ln x, that's going to be positive infinity. Just keeps going up. Any local extrema, no. Any asymptote, yes, x equals 0. There's a vertical asymptote. Hey, you, good.
I should take questions.
Fire away.
You say not bounded below. What does it mean?
That means that there's no horizontal asymptote.
Is there a horizontal asymptote?
For ETX, not natural log.
Logs don't have horizontal asymptotes. It's vertical, right? There's no ceiling, there's no basement. It goes up forever, goes down forever. It goes down forever really quickly because of its exponential nature, but it goes up very slowly. So graph the following and the respective inverse function on the same set of axes. Let's do this right now. And then their inverses, okay. That's not too hard, right? Easy peasy, right? Not too hard. Okay. So let's generalize here. We have a to the x. The inverse function is log base ax. For a to the x, the domain is obviously all real numbers. The range is from 0 to infinity. And it's reversed for this, right? Again, it's log base ax from 0 to infinity. And what happens if a is between 0 and 1? Well, nothing really. I mean, say, for example, you have like a equals 1/2. So then the inverse is going to be y equals log base half x. So if you make a table for this, 0, 1, 1, 1/2, -1 and 2. Let's see here. So you swap. Hold on. Yeah, it's kind of weird, but kind of looks like that. So now we're defining a log function, y equals log base ax, if only if x equals a to the y power. We know this already. And a is the base, of course. Any questions so far? No? All right, let's transform. Well, I'm just kind of pace myself here. It's not too bad. We're almost done here. I know I'm going kind of fast here, but use cloud method if you guys want. But honestly, when you get very good at this, we kind of know what to plug in, right? Like I can't plug in 3. What if I plug in 4? What am I gonna get, guys? 1 actually. You see why? You have log base 2 of 1, which is 0. No worries. It's all good. If I plug in 5, what do I get? 2 now. And I'm gonna plug in 7. What if I plug in 7? What do I get? 3. So 4, 1, 5, 2, 7, 3. And where's your vertical asymptote, by the way? Okay. I'm here. Let me think about this one. So you have to flip. Yeah, let me just start with the parent function first. What was the base for this one, guys? Yeah, so actually, you know what? I think we just go straight to a table. What if I plug in 1/5? What do I get? Good. What if I plug in 2? Negative 1. Yep. Let's try one more. What if I were to plug in? I don't want to do a number too large, but shoot, I guess I would have to do it kind of large.
It's 20.
Yeah, I guess if we do 20, it's -2, right? So 1/5 comma 0. 2 -1. And whoa, way over here, right? Kind of like that. And it's definitely a vertical asymptote here. At x equals 0. Any questions? We're good? Okay. Here, yeah, being kind of lazy, but I guess if we, yeah, Brooke, go ahead. You can actually, yes, that's that good observation. You could say, for example, so y equals 2 times ln of negative x plus 3. So you could make it y minus 3. The y minus 3 over 2. And then negative x equals e to all that junk. Not sure if I do all that. Does this feel like a lot of work? I don't know. Actually, more thing, I don't like that. Sorry. I see what you're saying, but let's just look at the parent function, which is pretty obvious, like 1 e 1, and then 1 over e -1. Well, you're going to switch the signs of x to be negative for sure. And multiply by 2 and add 3. Multiply by 2 and add 3. Multiply by 2 and add 3. So e is like 2.7, 5, -1, 2e plus 3, gosh, 5.4 plus 3, but 8.4, I think. Then -1 over e kind of 1. Looks like a decimal kind of. Wait, did I make a mistake somewhere? Hold on, I must make a mistake somewhere. Hold on. Oh, -2. Wait. When I plug in negative, okay.
Yeah, 1 should be 0.
Oh, wait, hold on. Natural log of, oh, that's 0. You're right. You meant this, right? Sorry about that, guys. You meant that to be 0, right? Yeah, I knew something was off. Okay, let's try it again. Multiply by 2 and add, so that's 3 now, right? Okay, that's better. And then if I plug in, that's negative e. If I do negative e, okay, so if I multiply by 2 and add 2, that's 5. Okay, that's better now. There we go. Or maybe 2.7. Here we go. And this one's going to be 1. Yeah, so the graph is going to look kind of like this. There we go. And it gets reflected about the y-axis. Okay. A little mind bending there. Let's look at this one here. What if I plug in 2? What do I get? 0. Plug in 1.5. You get 1. If I plug in, say, 3. Yeah, -1. Good. 2, 0. Yeah, there we go. Okay, we're cool there. All's good. Okay, cool. Okay, last one. Yeah, I'm just gonna get kind of lazy here. I'll plug in 2. I'll plug in 1. I'll plug in -1. If you plug in 2, what do you get? -1. Plug in 1, what do you get? 0. Plug in -1, what do you get? Good. Hold on a sec. The vertical axis was at 3. There you go. Just like that. Okay. So yeah, once you kind of really have a strong command of how the logs work, it's pretty easy what to do. Any questions? No? Okay. Well, that was easy. So you guys have a half hour to get homework done. Here's the homework. Probably can knock this out, guys. And the answers are right here. And again, I think we're starting calculus after this. No, we still got another unit. Sorry, I lied. We got sequence series. Then we do calculus after that. Okay. That's a fun one. I like that one a lot. I could really challenge you guys in that kind of stuff.
Oh, that's right.
So.
Was there anything special